Section 1.5 is about solving inequalities, just a review of inequalities and how we've learned them in the past. We'll start with this thing called the trichotomy property. It's also called the property of order. And basically it's saying that if you have two numbers, the first one has to be smaller than the second, it has to be equal to the second, or it has to be greater than the second. Those are the only three possibilities when you have two numbers. Then we have the properties of inequalities, which we use all the time, that simply say that you can add the same number to both sides and the equation can be balanced, or in this case the inequality can be balanced, and it works the same for subtraction. It just allows us to add and subtract things from both sides and keep the inequalities balanced. Here's an example. We have this inequality. I have letters on both sides. I always want to move the one with the smaller coefficient, so I'm going to subtract the 6x. Now, because I'm subtracting 5 over here, I'm going to add it, and it's okay to do it to both sides. So x is greater than 9. So this would be my solution. Down here, if I'm going to graph it on a number line, I'll make a number line that has a 9 on it. I'll put an open circle on 9. Open because this is greater than only, so we don't want to include 9. And I'll do my shading to the right because I want to talk about every number that is bigger than 9. But not including that. Here we have the other two properties of inequality, the multiplication property and the division property of inequality. And they say that when you multiply by a positive number, like you see here, the sign stays the same. It's a less than and it stays as a less than. But when you multiply by a negative number, as in this step here, the sign goes from being greater than to switching to less than. And that's the key. If you're multiplying by a negative number, you reverse the symbol. Same thing for division. If you divide by a positive, everything's good. But if you divide by a negative, as in this step, you go from a greater than to a less than sign. And this is really the key to both of these properties. When multiplying or dividing an inequality by a negative number, reverse the symbol. So here you see an example using the division property. The negative 0.25 is connected with multiplication. So we will divide both sides by it. We end up with a y on the left side. Now 2 divided by 0.25 is an 8, and because there's one negative, it's going to be a negative 8. But the more important step is to reverse this symbol because we divided by a negative number. So this is my solution, and if I graph it, I'm going to put a closed circle on negative 8 this time. Closed because it's less than or equal to, which means negative 8 can be included. And I want all the numbers that are smaller than that or less than negative 8, so I shade to the left. Now there's a couple other ways to write this solution, and they're given to you down here. One's called set builder notation, and here's how you write it. Use squiggly brackets. You put the domain variable, in this case a y, and then you use the actual solution followed by a squiggly bracket. That's called set builder notation. You're going to see the back of the book potentially use this. I don't mind if you just use the y less than or equal to negative 8, but you should know about it. Likewise, you should know about interval notation, which is kind of interesting. It's another way of writing a solution using these symbols. This is positive infinity, and this one is negative infinity. And this just means forever in the positive direction and forever in the negative direction. Now, if I want all the values that are smaller than negative 8, that means I'm going to go to negative infinity, and my upper bound is going to be an 8, and because it equals 8, I'm going to use a square bracket. If it doesn't equal, then we use a parenthesis. So this is how interval notation looks for this particular example. Here's an example we will solve. I'm going to begin by getting rid of the division of 9 by multiplying both sides by 9. So negative 9m less than or equal to m plus 4 because the 9's will cancel. Now I'm going to bring this negative m over here. Typically I wouldn't do that, but I want to show you what's going to happen. This is a negative 10m is less than or equal to 4, and now I'm going to multiply by a negative. And that's why I brought the m over, because I wanted to multiply by that negative to remind you to reverse the symbol. So negative 2/5. So we're going to write this now in interval notation. So we want all the numbers that are bigger. So negative 2/5 becomes the smallest, or the left bound of my interval, and it equals. So I'm going to use a square bracket, and it's going to go on to positive infinity. And we use an open bracket. So that's what it looks like in interval notation. And now we'll graph it. So here's what it looks like graphed. Negative 2/5 with the closed circle because it's equal to. And then here's what it looks like in interval notation. Here's a real-world example using inequalities. The situation is Greg delivering boxes of paper to a floor, and each box weighs 64 pounds. Craig weighs 160 pounds, and the maximum capacity in the elevator is 2,000, and how many boxes can he take on the elevator? So we have to be under 2,000 pounds. So we know that 2,000 is kind of going to be the maximum, and if I'm going to be under that, I have to be less than or equal to. If that's the capacity, it could equal 2,000 pounds, so we make that less than or equal to. Now we know Craig weighs 160, and each box, this is kind of the key here, each box weighs 64, so we're going to take Craig's weight and add to that 64 pounds for every box, which means X, my variable, is the number of boxes that I can take, and that's also the question that we're being asked. It's always good to set up a variable that matches the question. So this is the inequality that we will solve. Subtract 160. Divide by 64. So X is less than or equal to 28.75. Now what does that mean? That means he can carry 28.75 boxes. Well, carrying 0.7 boxes is not feasible. So we would say that it's safe for him to carry 28 boxes is the maximum number he can take and be safe.